Hello, we're going to do a bit of algebra practice today before we go back to our compound percentages that we've been learning about yesterday. So I want us here to be able to multiply without showing any working. Okay, so remember how we do that is we get the first thing squared, so that gives us x squared. We get the two things multiplied together twice, so that will give us 5x twice. So that's 10x, and we get the last thing squared, 5 5s are 25. So remember, we don't need to write down any working for this. Okay, if you're squaring out a bracket, you get the first thing squared, you multiply the two things together, you get negative 3t there, and you double it, so that's minus 6t, and then you have this squared, so negative 3 times negative 3 is plus 9. And remember, regardless of whether you've got a plus or a minus in the bracket there, this last sign is always plus. Okay, the next one. So the first thing squared, 4u times 4u is 16u squared. 4u times negative 1 is negative 4u, so double that, get minus 8u, and then you square in the minus 1, so minus 1 times minus 1 is plus 1. And then the last one, first thing squared is 64. Multiply the two together. 8 times 3c is 24c, so 8 times negative 3c is negative 24c. And we need to double that, so we get minus 48c. And then this squared, negative 3c times negative 3c is plus. 3 3s are 9, c times c is c squared. So remember, we normally write it with the squared term first, and then the letters and the numbers on the end. Okay, but when you're rearranging, do make sure that you stick with the correct signs. Okay, so well done if you remembered how to do that. On Teams, I have issued a list of all the lessons that we've done right up until the end of last week, and it's got what topics covered in each lesson, and there's a link to each video. So if there's something specific that you want to go over, then you'll be able to find it quite easily from that list. Okay, so what we've been doing recently though is fractions work, and then we went on to percentages. And yesterday we looked at calculating compound percentages, and I just think we could probably do with a bit of practice that today. Okay, so here we are. We're just going to go straight on to these questions, and I want us to remember that the way we calculate these is we start with our original value, we times it by the multiplier, which I've called m, and m needs to have a power, and the power is how many times we need to multiply by this multiplier. Okay, so for example, a boat's value falls by 7% per year. Chris bought a boat for £2,300 6 years ago. What's it worth now? Okay, so we need to find our multiplier first. So we're always starting off with 100%, and the value falls by 7%. So that means that we've got 93% of the previous year's value. Okay, then we need to change that into a decimal, so we divide by 100. And all we need to do now is what we've got here. So our original value is £2,300, times by the multiplier, which is 0.93, and the power is 6, because that reduction of 7% has happened 6 times in a row. So that's all we're working out is 2,300 times 0.93 to the power 6 is 1,488.0774, and other numbers, so in money 1,488.08. And it might be in a question like this that you're asked to round to a certain number of significant figures, but I'm not going to confuse the issue by dealing with that just now. So that would be our answer. So remember, all we need to do is find the multiplier, write down what we're working out, and go straight to the answer. Okay? You might not have to write that down. If you can do that in your head, don't write it down. It's up to you. Okay? Now, a bank account pays 1.3% interest per annum. Find the amount of interest gained on an investment of £2,800 after 5 years. Okay, so we're starting off with 100% and it's interest, so we're adding 1.3. So altogether, we've got 101.3%. So when we change that into a decimal by dividing by 100, we get 1.013. So that's our multiplier. So we're doing 2,800, original value, times the multiplier, and then the power is the amount of times this percentage change has happened. So when we work that out on a calculator, 2,800 times 1.013 to the power 5, we get 2986.7939 and some other numbers. So in money, £2,986.79. Okay, that's all we need to do to find the amount in the account. Okay, but let's just read that question again. A bank account pays 1.3% interest per annum. Find the amount of interest gained on an investment of £2,800 after 5 years. So this question is not asking how much is in the account. It's asking how much interest have you earned. So we need to then work out how much we've increased from 2,800 to this amount. So we're going to do £2,986.79, take away 2,800, and that'll tell us how much of the amount that's in the account now is the interest. So it's £186.79. Okay, so that's the amount of interest. Okay, so read the question carefully. If it wants the amount in the account, you're just working out the percentage and then doing this little formula. If you want the amount that's been added or lost, then you need to do a subtraction. Okay, so next one. Since Dee bought a house for £135,000 3 years ago, the annual appreciation rates have been 1.5%, 2% and 2.1%. So that means for each year. So the first year, that was the interest, the amount the house price had gone up by. That was the second year and that was the third year. Find the current value of Dee's house. So we need to look at these multipliers. All right. So let's just find the multipliers that go with each of these percentages. Okay. So if it was increasing by 1.5%, you'd have 101.5%, which would be a multiplier of 1.015. If you're increasing by 2%, you end up with 102%, so that would be 1.02 for a multiplier, and then 2.1% would be 102.1%, so that's 1.021 as a multiplier. So this time, instead of increasing by the same percentage over and over, we're actually increasing by 3 different percentages, but we still do it the same way. We start off with our original value, and then after 1 year, that would give us the value. Okay. After the second year, we'd be needing to multiply by 1.02, and after the third year, we'd be multiplying by 1.021. Okay. We can work these out separately. So if we'd wanted to, we could have said, right, we'll cut off there and work it out, and then multiply our answer by 1.2, and then write down what that is, and multiply that by 1.021. But there's no need to do that. We can work it all out in one go, just what we've got written down there. So 135,000 times 1.015 times 1.02 times 1.021. So altogether, you get 142,700.5755. So if we change that into money, because it's a house value, it's 142,700.58 or £142,700.58. But like I say, the pence don't matter when you're buying and selling houses, do they? Okay, so that's that one, and I think I might have one more example. I do, yep. So a new car's value falls by 15% in the first year after purchase, then by 11% per year after that. If a new car costs £15,290, calculate its expected value in 4 years. Okay, so if we're falling by 15%, we've got 85% left. So our multiplier there is 0.85. Okay, if we're falling by 11%, that gives us 89% left. So our multiplier is 0.89. Okay, so we're starting off with our original value, 15,290. So in the first year, the car's value drops or falls by 15%. So it's this multiplier for the first year. Now, it falls by 11% per year after that. So that's every other year it falls by 11%. So if we're calculating the expected value in 4 years, so for the first year, it would be dropping by 15%, like we've got here. But for the other 3 years, it would only be dropping by 11%. So what we're working out there is our original value. That's after 1 year, and that's after another 3 years. Okay, so working that out on a calculator. Is 9162.1296 and some other numbers. So £9,162.13. Okay, so remember, you don't have to work out the value at the end of each year. Even if you've got different percentages for different years, you can still just do it all in one go like this, and it's really hopefully reducing your chances of making mistakes. So you can go and practice this just now. There are very similar questions to these in your practice questions. Well done.